Integration is a fundamental idea in calculus. It's how we would find this shaded region, the area underneath a curve. In order to do so, we must first find the antiderivative of this function. You can think of an antiderivative as asking, given the slope, what did the graph look like in the first place? For example, the antiderivative of y equals 1 is y equals x, since the graph of y equals x has a slope of 1. It is working backwards from the slope to find the original function. Once we have the antiderivative, we evaluate it between two x values to find the total area underneath the curve. And that's integration. Sometimes you have to integrate weird, complex equations that look like gibberish and graphs that look like toddlers scribbled them. At that point, trying to solve the equation directly is like dumping puzzle pieces on the ground and trying to solve it piece by piece. With u-Substitution, you get to just take all of the weird-looking stuff and make it simple by temporarily renaming it to u. It is the most efficacious tool for lazy mathematicians. After substituting u, solving the equation becomes simple. Once we isolate u, the problem suddenly looks familiar again. Next, we take the derivative of u with respect to x, giving us du. It's just like finding the slope of the inside function. Finally, we substitute du into the integral, and boom. We can integrate it just like a standard, simple calculus problem. I didn't change any of the math, I just changed what I was looking at. I changed my focus. We do the exact same thing when we solve puzzles. We don't just try to do everything at once. We organize it piece by piece and then go from there. The same idea applies way beyond calculus. Let's take electrical engineering, for example. In real life, electricity is messy. Materials resist the flow differently depending on temperature, current changes over time, voltage drops. If you tried to calculate everything at the electron level, it would be impossible. Instead of tracking every electron, they use idealized components. A resistor represents any material that resists current. The battery provides voltage, and the wire is the conductor. These are then conducted into a simple loop that behaves like a real circuit. Just like u-Substitution, the complexity doesn't disappear, it's deliberately isolated so the structure of the problem becomes visible. U-Substitution is like sorting a messy puzzle into edge pieces, corners, and colors. Once the pieces are organized, the path to the solution becomes obvious. And once you learn to do that, calculus, or really any tricky problem, stops feeling intimidating and starts feeling like a game.